Okay, today is February 9th, 2012. We're going to go quickly over simplifying like terms. Now, I've given you a very large polynomial here. We have 1, 2, 3, 4, 5 separate terms, it looks like here. What I want you guys to recognize with these terms is that this is actually simplified. This cannot get any simpler to this question because there are no like terms here. And what I mean by that, in order to find like terms, first of all, I'm sure you guys have all realized, our coefficients. We have a 3, a 4, a 2, a 5, and a 4 is a constant number. That might look like something you want to put together, but they're attached to variables, okay? So the very first one is attached to the variable x, and it's to the power of 4, which is important. The only other terms I could put that with would be if I had another term that was, let's say, 4x to the power of 4. Then I could put it together with those coefficients. But because all of these variables have different exponents to them, we're unable to put them together. So I have x to the power of 4, the only one of its kind. X to the power of 3, only one of its kind. X to the power of 2, only one of its kind. What power is this x to? 1. Okay? Now, constant number. If sometimes people decide that they're going to put constant numbers together with variables, I want you to think of it like this. Our constant number, we could say it's to the variable exponent 0. What is any number to the exponent 0? 1. Okay? And what is 1 times 4? 4. It'll keep the number the exact same, but it'll give you that idea that the variable is to a different exponent, okay? To the exponent 0. So again, because its exponent is different than this variable's exponent, we're unable to combine those like terms, okay? Okay, so we've written out an example here, question 2c. First of all, this is going to deal with some of our distributive properties, okay? I need to distribute the number in front of the variable to each of the numbers inside of the brackets. Now, think of BEDMAS. I know you guys would think, okay, let's deal with what's inside the brackets first. But technically, these are not like terms. I have an x and I have a y. I have an x and a y. So because I cannot simplify what's in the brackets, I'm going to distribute my 3. I distribute the 3 to both numbers. We end up with, what is 3 times x? Just 3x. And 3 times 2y? That's right. We just multiply the coefficients. So 3 times 2 is 6. We get 6y. Now with our other number, is it just 2 we're multiplying? It is a negative 2. So when I multiply negative 2 times x, what do I get? Negative 2x. Negative 2 times positive 3y. Negative 6y. Now when we go take a look at these, what are my like terms? I have 3x and negative 2x. And I have 6y and negative 6y. What will happen with the 6y's? They're going to cancel each other out. And 3x minus 2x? So our answer is just x for 2c. Okay, same idea. I need to work with my distributive property. So I'm going to do this quickly. And I'm going to talk through it as I go to the next line. Okay? Now in the first one, 2 times 3, 6. And 2 times x, plus 2x. Now, this is where it gets a little trickier, okay? So we did this to start. 2x. What is 2x times x? 2x squared. So we have plus 2x squared. And the reason we have our squared x is because when we multiply x times x, so think of it like this. Remember we did those exponent rules? This is to the power of 1 and 1. We multiply, same base, we add the exponents, x squared. Okay? So we have 2x squared. And what is 2x times negative 2? Negative 4x. Good. And finally, now I have x squared. What is x squared times 5? 5x squared. What is x squared times x? X cubed, or x to the power of 3. Okay? Now, remember what I talked about where we needed our exponents to be the same variables. So we got to look for our like terms here. Do I have any other terms that have a power of 3, variable to the power of 3? This is the only one of its kind, so I'm going to start my polynomial with that. Then I'm going to look for ones that have squared. Do I have any that have a squared, like 5x squared? 2x squared. Those are going to be like terms. So when I combine them, what do I get? Now remember, I'm still going to have x squared. We just add the two coefficients. So we have plus 7x squared. Then I look for another. What about x to the power of 1? There's 2 of them. I have 2x and then negative 4x. When I combine those, what will I get? Negative 2x. And finally, I only have one constant number. Plus 6. So this is a simplified question. I cannot simplify this any farther because each of the variables have different exponents.